Good morning, everyone. Today we're going to be looking at another section of our ocean unit, and that is going to be on the ocean in motion. Whoa! Do you feel movement? Oh, okay. Well, let's do some juicy, get our brains moving and grooving. Who can tell me, and you can scream it at me, I'm sure I can hear it at my house when I'm working. So if you can scream it to me, do you know the 4 ocean land formation? Do what diddy dum did. Oh, continental shelf, continental slope, continental rise, abyssal plain. Yeehaw! That's right. Those are our 4 ocean structures that we talked about in the last lesson. Make sure you kind of keep your brain juicy. Does anybody know what is the V-shaped formation in the ocean that is formed by convergent plate boundaries when they squeeze each other? A trench, correct. What is the mountain chain that's formed by divergent, because you're breaking up is hard to do, boundaries? They're the mountain chains, the mid-oceanic ridge. Right, so keep your brains juicy. Juice. All right, now let's get some motion in our lotion. Oh, no, I mean ocean, not our lotion. Motion in our ocean. Okay, here we go. All right, the first ocean motion we're going to talk about is the wave. Hey! All right, ocean waves is the water in the ocean that is constantly moving. To be honest with you, we have to have movement in our oceans because it keeps our water fresh and clean and gets the oxygen moving. It moves the poop. So we have to have ocean motion. So there's a lot of benefits to this movement. So the ocean waves is one way we keep the ocean moving. On the surface, we see the waves. And if you look at the pictures, here are diagrams. If you've never been to the beach, you can see these diagrams. Waves are big circular formations of ocean water. Below the surface is that of the currents. Waves are on top, waves are on top, waves are on top, waves are on top, waves are on top. All right, put your hands up. Ocean currents are on the bottom. So we have ocean waves and ocean currents. They keep our water moving and keeping it clean, and moving trash and poop and keeping the oxygen level moving in the water. Waves. One of the things many people love about the ocean is the waves. People love to play in the waves, surf in the waves, and hear the sounds of the ocean waves crashing. If you look here, there is ocean waves. Ocean waves are caused by when wind blows across the ocean water. Blow across the ocean water. Now, one way that I help myself in remembering this is the process known as WWW. And so a long, long time ago, when we first started the internet, we always had to write www.com. Ask your parents. Now, when I think of WWW in oceans, I think, see my 3 W's, I have waves, wind, and water. So in order to have waves form, to make my WWW, I have wind, water, waves. In order to have waves form, I must have the water, I must have the wind blow across the ocean surface. Waves are a series of swells. Swells are rolling waves that travel a long distance through the ocean. They are not made up by local winds, but distant shores, distant storms way off into the ocean. Swells are typically smooth waves, not choppy like wind waves. So they are just constantly moving and pushing more waves in front of them. If you look at this, this is a diagram of a wave, and we'll talk more details because wave formation is used in a lot of different areas of science, such as sound waves and light waves. So one of the things, if you go on and kind of get these words in your head, it'll help you as well. If you notice that a wave also moves in a circular formation when wind blows across it or when the distant shores or storms are moving with them. We have what we have known as the top of the wave is known as the crest. The top of the wave is known as the crest. And when they come across the ocean and hit the beach, the crest comes and crashes onto the surface. So, and then we have what is known as a trough. And anyone that deals with farm animals know that troughs or what animals eat out of. It's the U-shaped formation of the wave. It's a U shape. And so, of course, you know, in me and studying, a lot of times I come up with ways to help me. Trough has a U in it. Trough looks like a U shape. Crest is where it crashes to the top. Crest is at the top of the wave. Trough is at the bottom of the wave, at the bottom of the wave. Now, wave length, think about wave length is the distance between two waves. Well, we know length is distance of an object, so wave length is the distance between the objects. This is a video that I'll be sharing with you. I'm not going to take time to show it now. On your time, you may look at it. There are some really good information in addition to these notes. Whoops, wait a minute. It's wanting to play. You guys are seeing my malfunction. Oh, no. All right, now I'm going to move my face again. Yay, you're super excited. All right, I moved my face for you. All right, guys, tides. Tides is the second ocean kind of movement. Tides is a daily thing that happens, and it's the daily rise and fall of the ocean level or any other body of water. And what happens is the moon has its own gravitational pull, and it's pulling on the land underneath the ocean or underneath the water surface as the Earth's rotating. And I always think of this. It's a bulge. It gets a big fat stomach on one side where the moon is pulling it. Where the moon is pulling it. Now, you guys got to see something. I was turning and looking for my rubber band that I thought I staved out. A rubber band is very much what the Earth is doing. If you look at this, if I am just on one side holding this, and if I'm the moon, I pull on one side, what happens? It pulls out. And that's what happens to the Earth's surface underneath the ocean water. It pulls, it bulges out. Well, guess what? When it bulges out, it runs out of room for the water on top of it. And so it pours out onto the ocean surface. So the tides are a cycle that repeat over and over and over every day. This cycle is a relationship between the Earth and the moon. As it's pulling, the gravitational is tugging and pulling on that surface and mounting it and pushing outward. That tidal pull and bulge is following the rotation of the moon as it revolves around the Earth. So as it revolves around us, different sides are being pulled. So if the moon's on this side of us, it's pulling on this side, on the right-hand side. Now, as I rotate, now I'm pulling on this side, and then I'm over here, and I'm going to pull on this side. So it's like a big fat stomach, because the Earth is not completely a circular, it's a sphere shape. So it's kind of like an egg. So it bulges in different places as the moon is pulling on it. Now, this is a diagram that shows how the Earth does this. So if you think about the rubber band, I have a hard time finding where I'm at, guys, sorry. And you pull at it. If my thumb is the moon, it's pulling up. If you look at this diagram here, here's the moon. It is pulling, it is bulging. It is pulling on the Earth's surface. It is bulging out. Where it has the highest bulge on both sides, just like a rubber band pulls on both sides, these two sides over here are having high tides. Look at those, how that they have both sides are being pulled in the diagram. The sides opposite of that are not being pulled, so therefore they have known as low tides. So the water, I always think of this system kind of like if I gave you a big cup of water. It's full. There is no more going to go in that cup. Then I looked at you and said, stick your hand in that cup. What's going to happen to the water in the cup? Yes, it's going to go pouring out. That's what happens to the Earth's water. The water is sitting on here on the surface of the land. And when this is pulling up, the water runs out of room and pushes onto the surface, causing high tides, causing more water onto the ocean surface, the continental shelf. Ocean tides hold on momentarily. My face is not in the right place today. All right. Ocean tides is a cycle that happens once or twice a day, depending on the location of the area of the moon. The location of the moon has the biggest effect on the tide, just like the diagram just showed. The moon pulls up on the ocean and the water pulls down, or the earth pulls down. The gravity of the moon causes high tides on both sides directly below the moon and on the opposite side of it. There are two movies.
It's sometime.
There are two movies in regards to tides that you can watch on your convenience that has additional information that I will have linked on Schoology. All right, the third ocean motion in the ocean is that of currents. Currents are ocean waters that travel in huge circular patterns, meaning in a circle formation. These huge currents move water of the world together, affecting the ocean's plants and the animals' life. They also affect the movement of the ships around the world. So they help move animals, because some animals don't have the ability to swim, so they help them move. They also help us with shipping and allowing the ships not to have to use as much energy, but use the energy of the ocean. There are surface currents moving water on the surface. They work with waves. And then there's deep water currents moving below the ocean surface. Both of those kind of give you the hint. Surface currents are on top, working with ocean waves. And deep water currents are deep in the ocean, moving the water. Deep water currents are important for moving temperature in our oceans. Now, 3 causes. There's lots of information on here. We're going to talk about each one of these. What causes this? And if you look on your notes, you will see that there are boxes, and they have you to fill in what are the 3 causes of currents. The first one is that of wind pattern. Wind pattern is the many large surface currents working with waves are caused when wind blows across the same direction all year long. The Gulf Stream runs along the east coast in the United States in the Atlantic Ocean, and it is one of the strongest currents. It is also what influenced the traveling of our explorers, which influenced our explorers coming to America because they used the Gulf Stream. Because if you remember, down in the areas of the times when our colonists were coming to America, there were not engines or motors on our boats. They used surface currents and wind in order to move their boats. It is like a river of warm water flowing deep on the colder ocean water. It is the one that moves the temperatures. So wind patterns is one cause of currents. The second cause of currents is temperature. Currents are also created by the change in water temperatures. Think about it. You know that all water is not always the same temperature in all places. Near the equator, the sun heats up the surface of the ocean. And as it heated the water, it becomes lighter and rises to the surface. And colder water sinks to the bottom. This up and down movement of hot and cold creates our deep water currents. It's what causes our equator not to be boiling and our poles to be completely frozen, because this deep water movement, it is moving warm water toward the poles and the cold water toward the equator. So we have a more balanced system of temperature in our oceans. All right, the first cause of currents, wind patterns, causing our surface currents. The second is temperature, keeping our water more moderate or in more regulated temperature level. Our third way that we cause currents is known as salinity. Most of you probably have never heard of salinity. What is salinity? Well, salinity is the amount of salt in the water. And this is how I, Miss Weikle, who helps herself study, is that salinity starts with S-A-L. Salt starts with S-A-L. So salinity is the amount of salt in the water. Not all water on our earth has salinity. Like our ocean, our river water, our ponds do not have salt in them, so they have no salinity. Now, but how does salinity affect our currents? The heat from the sun also affects the amount of salt in the ocean water. At the equator, the sun heats warm the ocean water. As that warm water evaporates, it leaves the salt behind in the colder waters. The more water that evaporates, the saltier the ocean water becomes. Salty water is heavy and it sinks. Less salty water rises to the surface and is lighter. The sinking and rising of the salt water also causes the deep water currents. So, warmer the water, evaporates the salt. The salt becomes heavy and sinks, and causes the colder water leaving it behind, causing also deep water currents. So surface currents are caused by wind patterns. So one causing of currents is wind. Temperature, moving it from the warm equator to the cold poles. And salinity, the amount of salt in the water. Salt is heavy, leaving it behind in the colder waters, causing deep water currents. Here is a diagram of currents. And if you notice here, the currents that are red would indicate warm water currents, and the ones here in the blue are cold water or deep water currents. Now, if you look at this current here, this is the most famous one for us in the east coast of the United States. The warm water comes out of the Gulf of Mexico around by Florida and heads north toward that of England, Scotland, and Ireland, what we call the United Kingdom. This is the most famous one for us because this is what the explorers and the colonists used in order to get to America. The Gulf Stream. It also influences your weather in the East Coast because it brings warm water up and keeps our water at a regulated temperature. Now, ocean currents, surface currents are usually caused by wind, and as wind changes, the currents may change as well. Currents are also influenced by rotation of the earth. This causes currents to flow clockwise. Everybody put your hand up. Clockwise, that means it's going to go from the middle all the way around. So think about the clock. So it goes to the right. In the north, it goes clockwise. In the southern hemisphere, it goes counterclockwise, meaning it goes to the left. I want you to go to your sink in your bathroom or your kitchen, and I want you to run a little bit of water. Then watch your sink. Not only does our currents flow the same direction, but our sinks do too. So our sinks in the northern hemisphere, because you are above this equator here, then your currents, your sinks are going to be moving clockwise. Now, if you want to go visit Australia, South America, Africa, then you're going to see the currents are going to flow to the left, counterclockwise. So do their toilets, and so do their sinks. Just some useless information in case you're on Jeopardy ever. Ocean currents, including the Gulf Stream that we just discussed, causes the wind patterns and differences in water due to primarily to the temperature differences. The ocean currents affect the mixing of ocean water, which affects the plants and animal population, which currents also affect the navigational routes, meaning how our ships travel in order to get supplies from different countries. Now, the Gulf Stream. The Gulf Stream is a strong ocean current that brings warm water from the Gulf of Mexico, just like we discussed, into the Atlantic Ocean, and then it extends all the way up through the eastern coast of the United States and into Canada, which influences the weather along those areas. I'm going to give you just some little information. If we want warm weather, we normally need warm air or warm current coming out of the Gulf. So of course we're going to have warmer water in the summer because the water are going to be heating there. Because if we go back to your information in 3rd and 4th grade about the earth with our seasons, the sun is closer to the earth during the summer, so therefore heating up our water. So that's why the waters are warmer in the summer than they are in January right now in the Atlantic. At Virginia Beach, Outer Banks, any of those areas, Ocean City, those waters right now would be very cold because the sun is not heating it up. But also, this Gulf Stream influences the British Isles, the United Kingdom, England, Scotland, and Ireland. It brings them warmer air, which gives them milder, less colder temperatures than normal. They're a very rainy country. Here's another video that will be listed on Schoology so that you may watch for additional information on currents. Some fun facts, just in case you needed to know. Some fun facts along about ocean motion. The tallest wave was measured to be 1,719 feet in Little Bay, Alaska. Tsunamis are huge waves of water that are caused by earthquakes or volcanic eruptions, not wind, not hurricanes, but because of the shaking underneath the Earth's surface of the land. A lot of times they happen in the Pacific Ocean because the Pacific plate is very active right now. Some marine animals take advantage of currents to migrate thousands of miles to their breeding grounds in order to reproduce and have new species. Surf up, dudes! Surfing is a hugely popular sport all over the world. They even have dog surfing competition every year in California. Don't think Bailey will do it. I don't know if any of you have been here, but she's been talking. She wants to say hello to you guys. I hope you guys are doing well. If you need me, email me, call me, touch base with me. I miss you. Love you.